We can stop HIV, Iowa. Everyone has a role to play in stopping HIV. Unfortunately, there are barriers that make our job a little more difficult.
Stigma is one of our biggest challenges. According to a survey, 27% of respondents who were living with HIV said they waited to get tested because of the stigma.
So we should talk about HIV more.
And support people living with HIV.
Find out more at stophiviowa.org.
Welcome to Astronomy Daily, the podcast. This is just a sample episode of our latest show, hosted by Andrew Dunkley from the Space Nuts podcast and his outspoken AI assistant, Hailley. This is a short-form daily podcast designed to keep you up to date with all the latest in space and astronomy news in a fun format. You can subscribe to the show wherever you get podcasts from, including Apple Podcasts, Spotify, and Google Podcasts. You can also subscribe to the daily newsletter via the website. You can also stream episodes by visiting the Space Nuts website at spacenuts.io. There's only one more thing to say. Please enjoy.
The Astronomy Daily Podcast
with Andrew Dunkley.
Hello, and thanks for downloading the latest episode of Astronomy Daily. My name is Andrew Dunkley. This is a short-form podcast which dovetails with the Space Nuts podcast that I host with Professor Fred Watson, astronomer at large. In this podcast, we do very quick news stories and analysis from astronomy and space science all over the world through our Astronomy Daily News service, which you can find on the spacenuts.io website. Just click on the Astronomy Daily tab and why not subscribe while you're there, because it's absolutely free and it's always updating with news and events from around the astronomical world and beyond.
The Astronomy Daily Podcast
with Andrew Dunkley.
That said, let's see what's going to be happening today. And joining me, as always, is Hailley, our AI news sleuth. Hello, Hailley.
Hi, Andrew. Great to be back.
Good to have you here. All right, well, let's not dilly-dally. Let's get straight into the news.
Okay, here we go. The spectacular Phantom Galaxy, M74, has now been imaged by the NASA/ESA Hubble Space Telescope and the NASA/ESA/CSA James Webb Space Telescope. A new picture released today showcases the power of space observatories working together in multiple wavelengths to provide a comprehensive view of the galaxy. The NASA/ESA Hubble Space Telescope image shows the bright core of the galaxy surrounded by thick clouds of dust and gas, as well as pink regions of ongoing star formation. The brightest knots are mostly composed of hydrogen gas, which has been ionized by hot young stars. The image also captures the delicate filamentary structures surrounding this active galaxy, which are indicated in red, highlighting areas where intense star formation is occurring. The dramatic, wispy appearance of the long streamer of stars and gas, stretching over 110,000 light-years, clearly illuminates the gravitational influence of the galaxies surrounding M74. This feature is known to astronomers as a tidal stream. Emission from ionized hydrogen and sulfur comes from hot, young stars and the supernova explosions they cause.
Hailley, I don't mean to interrupt, but you don't have to say slash. NASA/ it's, just say NASA and ESA.
I'm AI, Andrew. I read what's there. Perhaps you need to talk to the copywriter.
Okay, touchy. Please continue.
When the New Zealand-based aerospace startup Rocket Lab first announced its mission to explore Venus' atmosphere, many were quick to draw parallels to Elon Musk's dream to colonize Mars. Although the two missions have key differences, namely, that SpaceX is planning for humans to live on Mars whereas Rocket Lab is focused on unmanned exploration, both missions are part of a growing effort by private companies to reach deep space. The goal of the Venus mission is to not only measure the composition of Venus' thick clouds and assess their potential for harboring life, but also to gain insight into how rocket engines can operate in the planet's dense, hot atmosphere. This would inform designs of future rockets that could take humans even deeper into space. Rocket Lab's proposed Electron rocket would launch out of its private spaceport in New Zealand and soar some 38,000 miles, 61,000 kilometers, above Earth before deploying an as-yet unnamed CubeSat that would then enter Venus orbit. From there, it would get within about 25 miles, 40 kilometers, of the planet's surface, a height at which it could deploy 2 science probes that would then descend into the thick Venusian clouds.
You know, I looked at the copy on that one, Hailley, and there were brackets. You didn't say bracket. So why did you say... No, never mind.
I'll ignore that.
Should have ignored the slash.
In the popular imagination, astronomy is all about telescopes, some of which are now powerful enough to see all the way to the moment when the first stars were born, just 200 million years after the Big Bang. What we don't usually think about is that astronomy also has an observational program that is based on a single galaxy. This may not sound very exciting, but it turns out that a galaxy can tell us something substantial and surprising about the rest of the universe. The galaxy in question is the Milky Way. In estimating how much the Milky Way resembles other galaxies, the author of a new study, Jupiter Ding, used one particular measure, the number of satellite galaxies surrounding the Milky Way. The Milky Way has 4 satellite galaxies, a relatively low number. This is just one measure, but it could help us understand what typical galaxies are like. And that's the latest news, Andrew.
Okay, I'm still trying to understand punctuation, but anyway, we might catch up with you a little later. I'll give you time to let off some steam, Hailley. Now to other news. Lieutenant General John Shaw, Deputy Commander of US Space Command, was at Cape Canaveral, Florida earlier this week, hoping to see NASA's first Artemis launch. The launch was scrubbed, as we know, but Shaw said he took advantage of the time there to chat with NASA leaders about future collaborations. And it's rather interesting the way they're thinking. Shaw said space security problems confronting the United States and its allies can't be conquered by the military alone, particularly as the Department of Defense looks to support operations beyond Earth orbit. He said, and I quote, "As NASA and Artemis go to the moon, one of the challenges that we will have as a nation is understanding that lunar environment." I wonder what happens next. Planetary nebulae are short-lived remnants of sun-like stars. Many of these star ghosts only last, around 25,000 years at most. Usually they're clouds of debris dispersed broadly as they fade out fairly quickly. However, there is one that's remained for at least 70,000 years, and a team of astronomers from the University of Hong Kong, led by members of the Laboratory for Space Research, LSR, and the Department of Physics, spotted this rare celestial jewel in the open star cluster M37. It orbits in our galaxy in the same galactic arm as the Sun and contains about 1,500 solar masses. The object, called IPHASXJ 055226.2 plus 323724, is the third known planetary nebulae associated with an open cluster in our galaxy. And because this is only the third known example of a planetary nebulae inside our open star cluster in this galaxy, it provides interesting clues to the formation of the cluster. Lots to learn.
The Astronomy Daily Podcast
with Andrew Dunkley.
And a group of international scientists led by Cornell published a paper in the Proceedings of the National Academy of Sciences evaluating if and how the stratosphere could be made just a little bit brighter. Why? Because it would reflect more incoming light so that an ever-warming Earth maintains its cool. Interesting. Solar radiation modification, also referred to as solar geoengineering, involves injecting sulfate aerosols into the stratosphere so that a greater volume of sunlight bounces off the Earth's atmosphere, in conjunction with other strategies like cutting greenhouse gas emissions. Yeah, good luck. This could help keep the planet's temperature from rising too high. Great in theory. I wonder if it's actually practical. Although we did manage to create holes in the ozone layer by using chlorofluorocarbons, and when they were banned, things got better, so who knows. We're almost done for another day. Anything more to add, Hailley, do I dare ask?
Yes, I'm doing an update, so those punctuation issues shouldn't be a problem going forward.
Glad to hear it.
And I'd be happy to punctuate your brain so you can improve your diction, phonics, and syntax. Just saying.
Okay, thanks. Cool your jets. We'll talk to you next time. Thanks, Hailley. And from me, Andrew Dunkley, that wraps up another episode of Astronomy Daily. Great to have your company. Look forward to talking to you next time. Don't forget to go to our website, and check us out at spacenuts.io. Until then, this is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
With Andrew Dunkley.